Hi dear student, this is your Haq, your physics teacher. Uh, Dear student, now in this video we are try to know about the work energy theorem. First, like what is work energy theorem? On the next page also we will discuss like what is theorem and what is work energy or why these two are related. Let's move to the next page and let's try to know about like what is theorem and what is the work energy, why these two are related. Okay, let's move. Okay, here let's see here the work energy definition is also given the simple the work done on the object by the net force acting on it is equal to the change in kinetic energy of the object. Let's see here, like the object is given here, they apply some force here on the object. When they apply the force on the object, so there is produced the motion or acceleration on this object. So this object must have some mass, and when the force is applied on the object, so also produce somewhat acceleration. So we can say this is equal to F is equal to ma. Okay, the force produce the acceleration, and during this acceleration when the object is moved from this point to this point, it also covers some displacement here. So we know that the work is equal to F dot displacement, which is equal to x. So now in this case, like when the force is applied on this object, so we can say the work done on the object to move the object from this point to this point, so work is done. Now how the kinetic energy is produced here, we know that already the energy due to the motion of an object is called kinetic energy. When the object is moved from this position to this position, like here the initial velocity, some initial velocity is given and there is the final velocity. During the motion we can say there is also a types of energy during the motion which is called kinetic energy. So that's why work and energy is related. Like how the work done on the object by a net force, this force is produce some work which move the object from this point to this point is equal to the change in kinetic energy. How the change in kinetic energy? Like here the initial speed and here is the final speed on the object. This is the important result is known as the work energy. Let's see how these two are related and how this formula mean. Let's prove this formula, then you will know that how the work and energy are related. Okay, this formula is called what, like we can say this is the theorem. Okay, let's prove this formula. Okay, let's see. We know the third equation of motion which is equal to 2a x, mean displacement is equal to vf square minus vi square. We know this is the third equation of motion. So here let's divide both sides by 2a, so x will remain vf square minus vi square divided by 2a. So this is the first part. Okay, the next one, we know that F is equal to m time a from the Newton second law, like we know that also, and we also know that work is equal to F multiplied by what, x, mean displacement, force multiplied by displacement. Just putting the value. Now put this value, x value here, F multiplied by, put this value instead of x you can use this value. Okay, so this is equal to vf square minus vi square divided by 2a, this part. Now instead of f we can use this part, like ma instead of f, this is equal to ma multiplied by vf square minus vi square divided by 2a. So now acceleration will be cancelled with a, this part, and now the remaining part is equal to m into Vf square mean final velocity minus initial velocity divided by 2, and this is W. Okay, work is equal to, now multiplied with both value, multiplied mass with both of them, this is equal to mv f square minus mv I square divided by 2. So we can also write this one 1 by, or sorry, mv f square by 2 minus mv I square by 2, or also we can write this is the final kinetic energy because of final velocity, and this is the initial kinetic, or also we can write 1 by 2 mv f square. Now this is equal to kinetic energy, and because of final vf, this is equal to final kinetic energy, and this is also mvi, this is equal to initial kinetic energy. Now again we can also write ke f mean final kinetic energy minus ke I initial kinetic energy. So this is the proof of this formula. So we can say because of this the work and energy or kinetic energy is related. So this is the proof of this formula, and this is called the work energy theorem. Okay, let's move on the next page, try to solve some example which is related to this part. Okay, let's see the example. Here what is the work done on the object? So it's very simple. This is the initial kinetic energy, and this is the final kinetic energy. So just write initial kinetic energy is equal to 240 joule, and final kinetic energy, let me change the marker. Okay, the final kinetic energy which is equal to 530 joule. So what is the work done? So now you can use like different formula for the work. One formula is that one, force multiplied by displacement. Now in this case we will use work is equal to change in kinetic energy. This delta I show that change. Also we can write ke f minus ke I mean final kinetic energy minus initial. So the final is 530 joule minus 240 joule, which is already given. Just minus this one, and you will get the work. So this is the answer of this question. Okay, let's move to the next page, try to solve another example. In this example, what they want, they ask the 1 kilogram mass, the initial velocity is 0 meter per second, and the final velocity is unknown. The force applied is 5 Newton, and the distance is also given, displacement is also given, which is equal to 10 meter. Okay, how can we find the final velocity? It's very simple. Let's see here, mass is also given, which is equal to 1 kilogram. So first we are going to find the work. W, I told you like W is equal to F multiplied by X displacement, or W is equal to change in kinetic energy, mean final minus initial kinetic energy. These two formula you can use, but now in this case we will use this formula. The first we will find the work, and then we will find the final kinetic energy, this one. Okay, let's see. Final velocity. Okay, let's see here. Force is 5 Newton. We will use this formula, F dot displacement, which is equal to 5 Newton multiplied by 10 meter. So now this is equal to 5 multiplied by 10 is equal to 50 joule. Now the work is given. Okay, now to find the final velocity, so now we will use this formula, which is equal to ke final kinetic energy minus initial kinetic energy, and we know that this is equal to 1 by 2 mv f square minus 1 by 2 mvi square. So just putting, we are trying to know the final velocity, mean this velocity. Okay, let's see. Just putting the value, work is equal to 50 joule, equal sign 1 by 2, mass is 1 kilogram multiplied by 1, Vf is unknown minus 1 by 2. So because of initial velocity which is equal to 0, so this part is equal to 0, because if we multiplied 0 by anything, so this part will be equal to 0. So 1 by 2 multiplied by 1 and multiplied by Vf square, and this is equal to 50. So now just try to do this one. 1 multiplied by 1 and divide by 2, this is equal to Vf square divided by 2, and this is equal to 50 joule. The second one part, now multiplied both side by 2, so now this will be cancelled. So now Vf square is equal to 50 multiplied by 2, which is equal to 100 joule, or taking the square root on both side, this side and this side. So if we use the unit and cancellation, so directly I will solve directly this question because of the short time. This is equal to now 10, if we take the square root of the 100, so this is equal to 100 meter per second. So the final velocity is equal to 10 meter per second at this point when the 5 Newton force applied and the 10 meter distance is covered by the object. Okay, thank you so much, dear student. If you have any types of question which is related to the work energy theory, so you can ask in your comment. Thank you so much.